Hello everyone and welcome to TLE Eliminators Leetcode Post Contest discussions. Today we'll be discussing Weekly Contest 474. Yeah, let's see. So we'll be discussing all the questions A, B, C, D. And how was the contest? Just wait for some people to join, I guess. Hard, easy, good contest, cool, I guess. Um, how many did most people solve? So I expect A, B most people would have solved. ABC also, maybe some people, because C was a bit trickier than usual. I think, I mean, not trickier, just required some math knowledge. And D was a bit implementation heavy. AK, nice. All right, so most people solved two, so we'll quickly discuss solution of A and B, but then for C and D we'll spend some more time. Okay, so that's how we're gonna do it. Fine. So first problem: find missing elements. Given integer nums, we need to find basically the smallest and largest integers. We need to find that, and then in that range, whichever numbers are missing, we need to return that. Okay, so basically whichever is the smallest and largest, in that range, whichever is the missing numbers, we need to return that. So for example, if you take um, 5 and 1, so then smallest is 1, largest is 5, so 2, 3, 4 are missing. So that's what we need to return, a list of 2, 3, 4. Correct? So direct implementation question, nothing much to think about. I'll just tell you what my approach was. So my approach was like this. Problem A, right? And obviously there are many ways, because n goes up to 100, right? N goes up to 100. So almost any solution, even big O of n cubed solution, will pass, right? Even n cubed solution will pass. So it doesn't really matter that much. But my solution, I guess, is n. So n log n-ish. So here's my solution. Solution idea. Sort the given list. Once it is sorted, it'll obviously be in increasing order, right? So it'll be like, for example, 1, 2, 5, 8, 11, something like this, right? So now when it is in sorted in increasing order, between every adjacent element, whatever the integers are missing, we will add those to the answer. Okay, so here there's nothing missing. Here there is 3, 4 missing. Here there is 6, 7 missing. And here there is 9 and 10 missing, right? So our final answer is going to look something like, 3, 4, 6, 7, 9 and 10, right? That's what's missing. So all we need to do is simply for each adjacent element, so for each adjacent AI and AI minus 1, loop from AI minus 1 plus 1 to AI minus 1, like this. Add the missing ones. They'll all be missing, right? So add them to the list. Add them to answer. Then finally return the answer, right? I hope this makes sense. The time complexity of this will be big O of n log n, because we are doing a sorting, and that does make the time complexity worse, but then it doesn't really matter, I guess. You can use unordered map and achieve big O of n on this problem, or you can use arrays to hash, and then you can achieve big O of n on this problem. Cool. Problem may make sense. Let's have a look at the code. So there are many ways to code this. This is the way I coded it. Took the size of the array, sorted it, and then I have my answer array. For each element, we are starting at AI minus 1 plus 1, going up to AI, and we're pushing back that x because we know that now x did not appear, right, because it's sorted order. Then finally when the whole thing is done, we can just return the answer. Make sense, guys? Or another easy way to do is use unordered map. So add everything to unordered map, find the smallest and largest, and then between that you check if it's present in the map or not. So that's how you solve the first question. Let's move on to the second one. Problem B. Okay, I thought problem B was easier than problem A. So you're given an integer array nums. You must replace exactly one element with some value in the range negative 10 power 5 till 10 power 5. After performing this single replacement, determine the maximum possible product of any three elements at distinct indices. Okay. Return an integer denoting the maximum possible product achievable. So basically, when you choose three numbers, you can replace one of them with any number you want between this range, and then find the maximum possible product of this triple. Right? So how do we do this? It's also pretty simple. So since we are choosing the numbers for our triple ourselves, so we're basically choosing AI, AJ, and then X, which we are choosing ourselves, right? So we need to find the product, max product of AI, AJ, X. Okay, this is what we need to find. Now obviously we should make X as maximum possible, right? X should be maximum possible. So we'll keep X as 10 power 5 because we want to maximize this product, right? But this works in cases like A equals 2, B equals 3, X equals 10 power 5, then this will give us the maximum one, which is 6 times 10 power 5. Okay. But what if these two were negative? Okay. What if these two had a negative product, like one of them was negative? Then we'd get AI times AJ is negative. So then we want maximum possible. So we'll make this also negative, right? We'll make this also negative. So we'll keep X equals minus 10 power 5, right? Then X will be minus 10 power 5. So then again we get magnitude of AI times magnitude of AJ times 10 power 5, right? And basically that is our answer. So in the case that these are forming negative, we'll make X as negative. If these are positive, X will be positive. X will be as large as possible, right? So X can be at most 10 power 5. So our answer will simply be, equal to magnitude of AI times magnitude of AJ times 10 power 5. Now all we need to do is find the maximum AI and AJ, right? So take largest, and take second largest. Magnitude. Okay, magnitude. If you do sorting, then you can do this in big O of n log n. With some other ways to find the largest and second largest, you can do it in big O of n itself. But there's not much issue with sorting, so we'll just sort. Sorting will take big O of n log n. Cool, does it make sense? Let's have a look at the code. So n is simply the size of the array. For each element, we take its absolute value because we only care about magnitude. We sort it, take product of two largest magnitude and 10 power 5. We can return that. Cool. Yeah. All right, let's move on to problem 3. For Krishna, yeah, see, I understand that A and B was very simple, but there are people who watch the stream who are doing Leetcode for the first time ever, right? So for them, I'm explaining just 5 minutes, so it's fine. All right, let's move on to problem 3. Okay, so you're given two integer arrays, basically d1, d2, r1, r2. Basically what it means is you're given two drones, d1 and d2, and drone 1 must complete d1 deliveries, drone 2 must complete d2 deliveries. each delivery takes exactly 1 hour, and only one drone can make a delivery at a given hour, right? So both drones cannot do delivery at the same time. Additionally, both drones need to recharge at specific times. So every uh, hour which is a multiple of Ri, that drone should recharge at that time. Return an integer denoting the minimum total time required to complete all deliveries. And there are some examples. So this question, you do some examples to understand. So for example, drone 1 needs to make 3 deliveries, drone 2 needs to make 1 delivery, and it must recharge at 2, it must recharge at. So let's get that. So okay, so let's just draw like when the drones are free. Okay, so this is the different hours available. Okay, so like hour 1, hour 2, hour 3, 4, 5, 6, so on. This is drone 1 and drone 2. Okay, so drone 1 is not available at multiples of 2. Fine, drone 1 is not available. Drone 3 is not available at multiples of 3, right? So now we need to find the minimum way to do deliveries, right? So now obviously whenever drone 2 is not available, right, then we'll use drone 1. When drone 1 is not available, we'll use drone 2. If both are not available, we can't deliver anything at that hour. So that's kind of how we're gonna stack our numbers. So let's say drone 1 is 3, then basically what we can do is yeah, so drone 1 can deliver at this time, and this time. Drone 2 here can deliver at these 2 times when this one is unavailable, right? Whenever this one is unavailable. So that's basically a solution for this, and that's why the answer for this is the minimum time is equal to 5, right? The minimum time is equal to 5. Okay, let's take another example. Let's say we have, or let's take another example here itself. Let's take r equals 3, 4. So we'll have okay, we have something like this, fine. Then again we can draw something like that, drone 1 and drone 2. The first one will not be available every multiple of 3, right? So it won't be available here, 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 here, so on. Okay, this one won't be available every multiple of 4, so like this, and so on. Fine. Okay, so now obviously whenever drone 1 is busy, then drone 2 should deliver. So we already know that, so we can say that okay, definitely drone 2 should deliver here, and for example drone 1 should deliver here, right? Similarly drone 2 can deliver at this point and this point, right? So that's a like a rough kind of idea we have. Okay, similarly drone 1 gets this point as kind of available, so we kind of roughly know that that's true. Now in the remaining ones, it can be either drone 1 or drone 2 delivering, and then the choice is up to us. Okay, the choice is up to us which one delivers, and we kind of need to figure out how to distribute the deliveries of drone 1 and drone 2 such that they both deliver at the minimum time. Okay, so let's just make some arbitrary choices and see what happens. Okay, so let's just say that that here drone 1 itself delivers. Okay, these two drone 1 itself delivers, and then these two also drone 1 is delivering, and let's say here drone 2 is delivering. Okay, now drone 2 needs to deliver 6, so it delivers like this. Okay, so as you can see, every day at least one drone is delivering, so that's why this is an optimal solution to the question, right? And basically we have found a way to distribute drone 1 and drone 2. So that's basically what the question is asking. Okay, this question was asked in Amazon away. That's interesting to know, right? So the approach to this problem is going to involve binary search. And basically the idea, like Hemang has asked, can you tell me why it had binary search concept? Isn't there a way to solve it using formula? I wasted my time deriving. So yeah, initially this question does look like you will solve it with some math formula, but after trying out different math formulas, you will see that okay, it's becoming pretty complicated. And I'll get into why binary search. So okay, so if you try to figure it out by a formula, right? Let's try to make some kind of formula for this. Fine, let's try to make some kind of formula or some kind of greedy /greedy, right? What you're basically going to see is you're gonna not understand when to put the first one or when to put the second one, because like for example, if there was a case like this, okay, where this one was not available, these are available, then you need to know that you must use the second one here and the first one here, right? If you had to just use the first one. So basically your answer depends on the future position of x's, right? Your answer is depending on your current answer depends on where the future position of x's are, as well as your d1 and d2. So whatever your formula you're going to derive, it's going to become pretty complicated if there even exists such a formula, right? So the way I was doing it was I tried to sit down and find some formula, but then it didn't work for like 10-20 minutes. And then it hit me that we're doing a minimization problem, right? So we are trying to minimize the total time to complete all the deliveries. Okay, so whenever you have a minimization maximization problem, okay, whenever you have a minimization maximization problem, there are only three approaches. Okay, there are only three approaches, right, that we commonly used in CP. Okay, the first approach is obviously greedy or math, right? Some greedy / math. Second approach is DP, and the third approach is binary search, right? These are the only main approaches to find some minimum or maximum that we have learned of in CP, right? And when you try to do a greedy or math formula and you don't get it for some time, you should start thinking of other approaches. If you start thinking about DP is obviously not possible because this goes up to 10 power 9, right? And even R goes up to this. So if you try to DP it won't work. So you can just cross off DP from the list. Fine, you can cross off DP from the list, and you're left with basically either doing some kind of math or doing some kind of binary search. And when your math isn't working, your brain should try to think of an alternate binary search idea. Isn't binary search greedy? No, binary search is not strictly greedy. Binary search and greedy are different topics, I would say. They use a different kind of idea. Like your binary search check function might be greedy, but your check function, your binary search can be DP sometimes. It can be many things. So binary search is not greedy. They're quite different techniques, right? Anyways, so then you'll think of one of these two strategies, right? So I guess it comes with practice, but usually when you're not able to solve a problem directly, right, when it becomes very complicated, you also know that this is a C problem on Leetcode, so it will not be that hard, right? It won't have some very large formula or big combinatorics derivation. Then your brain will start thinking about, okay, can I binary search the answer? So yeah, it comes with a bit of experience and some intuition to know that you need to binary search, but okay. And also I'll tell you from the point of view of the check function, right? If you start thinking about the check function, start thinking in this way. Given some amount of time, start thinking in the binary search ways, like given some amount of time, amount of time can I deliver all the packages or whatever deliveries there are, right? That's the basically the question with both these drones. So if you start thinking that point of view, you'll get the idea to binary search pretty quickly, right? And also it's a long answer which you need to minimize. I need to find the minimum total time. It does like bring binary search into your mind, like depending on how familiar you are with binary search, that thing will come to your mind faster, I guess. But okay, so given some amount of time, can I deliver all the packages? Let's try and think about this. Okay, because if you try think about the math equation, it'll be pretty complicated to do it directly. Okay, fine. So given some amount of time, can I deliver all the packages? Let's imagine that again we have some delivery slots for drone 1, delivery slots for drone 2. Okay, let's say drone 1 is not available every 3 as before, it's not available every 3, and drone 2 is not available every 4. Fine, not available every 4. Okay, something like this. So basically what we observe here is that, let's say the number of deliveries drone 1 needs to do is D1 and the number of deliveries drone 2 needs to do is D2. Okay, so D1 comma D2. Then what we can do is basically we can end whatever D1 plus D2 is a D1 plus D2 here. Okay, this was 1 plus D2. Then basically we can arrange D1 and D2 in such a way, right? We can arrange D1 and D2 in such a way such that it occupies all these positions, like in the position wherever there is conflict, in that D1 can occupy, and the position wherever there's conflict this way, in that position D1 can deliver, right? Whenever D2 is out of commission, D1 can deliver. Whenever D1 is out of commission, D2 can deliver. So basically that can be our idea, and then remaining days we can just choose whichever wants to deliver, and we can deliver it, right? So we can complete it by the time D1 plus D2. Okay, we can complete it by time D1 plus D2. What about the cases when both cannot deliver, right? So there'll be some days where both cannot deliver, like for example, if our delivery was somewhere here, right? If D1 plus D2 was this, till here both cannot deliver, right? So we can say that, okay, like this position both cannot deliver, so our answer will increase by 1. So our answer will take total D1 plus D2 plus basically what we're saying is this many deliveries we can take, right? So that's basically how we're going to fill it up. Okay, so basically what I'm trying to say is, given our total time is, let's say, t. Okay, our total time is t. Then for each time we can do one delivery, right? For each time we can do one delivery, which can be from drone 1 or drone 2. So that will be t plus t divided by LCM of R1 and R2. Okay, LCM of R1 and R2. And I'm basically saying that we can choose to do delivery from drone 1 and we can choose to do delivery from drone 2 in such a way that our total time, if we have a total time of t, then we can do deliveries t plus t divided by LCM of R1 and R2 by appropriately distributing D1 and D2 whenever the other is not available, right? Sorry, it should be minus over here because that's how many deliveries we can make, right? So our deliveries should be less than equal to this, right? So basically D1 plus D2 should be less than equal to this number. So let's call this equation 1. Okay, now this is not the only condition. There are other conditions which also will apply, because what if D1 was very large and D2 is pretty small? So D2 can only fill the gaps, right? D2 only fills the gaps, but there's still empty spaces. For example, I'll show you what I mean by fill the gaps. So let me just cross some places out. Okay, something like this. And basically, let's say d1 is large, d1 is equal to 10, d2 is equal to 2. Fine. So since d2 is equal to 2, we'll deliver here once, and now since this is equal to 10, so 1 2 3 4 5 6, here no delivery happens. Okay, here nothing can happen. 6 7 8 9 10, like this it's going to go on, right? So not even 9 10, so there'll be an x and then 9 10, right? So as you can see, in this position and this position, a skip happened because there was nothing being delivered at this time, right? Nothing was being delivered at this time, so that's why we had to skip. This only happens if d2 gets used up in the gaps itself. This kind of situation will only happen if d2 has already been completely used up in these gaps, correct? That means d1 is much larger than d2, that d2 is able to fill the gaps of d1. Okay, d2 is able to fill the gaps of d1. Is this making sense, guys? Okay, so in this case, what is going to happen is the total time taken by d1. So if you're giving d1 some time t, then the time taken by t1 to finish is basically, let's write it like this. So given a time t for only t1 to complete, for only drone 1 to complete all its deliveries will be d1 plus, sorry, t minus t by r1, right? So that's how many deliveries I can complete in the given time. So I want, my condition will basically be d1 is less than t minus r1, right? Basically what I'm trying to say is, in the given time t, we are being limited by drone 1 being able to complete at most t minus t by r1 deliveries. Okay, this is the limit of drone 1. In a time t. This is limit of drone 2 in a time. This is a limit of both drones. So limit of drone 1 and 2 in time t. And then obviously there'll be a limit of drone 2 as well. It'll be the same formula but for drone 2. So for drone 2, same idea. We get d2 is less than equal to t minus t by r2, right? And this is our third equation. So let's summarize the three equations we got, and we can show that if all three conditions are satisfied, then in the given t we will be able to deliver all the packages. Okay, so given a t, this is basically a check function we're thinking about, right? So given a t, can we deliver all the packages? Can we deliver all packages in time? So the conditions we have is basically d1 plus d2 is less than equal to t minus t by LCM of r1 r2. d1 is less than t minus r1 and d2 is less than t minus t by r2, right? You can take a moment to convince yourself that if these three conditions are satisfied, then all the deliveries can happen, because basically what we're trying to say is, since d1 fits completely in the time, d2 also fits completely in the time. That means that whenever d1 is not delivering, d2 will be available to deliver, and whenever d2 is not delivering, d1 will be available to deliver, and we can fit them in. And in the times which both are not available, that is also being handled for, right? So basically, if these three conditions are satisfying, there will always be some arrangement to deliver the answer, right? And if any of these do not satisfy, then there will be no arrangement to give the answer. So that's why these are our conditions for our check function. You need to understand, like, mathematically what these equations mean. So if this is feeling unintuitive, I can understand. Like if you're somewhat new to binary search and these kind of greedy ideas, this would be unintuitive. But after a while, this becomes intuitive. And basically, the idea is that these three conditions are necessary, as we showed earlier, for deliveries to happen within time t. Now we'll show that these are sufficient also. This, so formal proof I'm not sure how to do, but the intuition, I think, is what matters for the problem. So the intuition is basically that if all these conditions are being satisfied, right, if all these conditions are being satisfied, it basically means, like, for example, there are two people, they both can finish the work in time, and also together also they can finish the work in time. Then in the places where the first person is not available, the second one will do, and when the second one is not available, the first person will do. When both are available, we can just choose between them. So basically that's what these two equations are saying. So I hope that makes sense. It does rely on some intuition. Like, you should have solved some problem like this before. Like, if you solved enough binary search problems, I think you would get it. But to convince yourself that this is a sufficient condition is not that easy if it's your first time seeing something like this. But if you think about it, it makes sense, because we know that D1 will definitely finish alone in this time. We know that D2 will also finish his deliveries alone, and both together can also fit in this, right? So that means that there will be some rearrangement of D1 and D2 such that they all fit their deliveries within this time itself. Oh, why is LCM present here? Okay, so I hope I did not explain that part. Sorry about that. LCM is present because we are just finding time are both drones not available. Okay, not available. Okay, so if you think about this, both drones will not be available when it is a multiple of LCM of R1 and R2. Why so? Because all multiples of R1 are not available for drone 1, right? All multiples of R1 are not available for drone 1. All multiples of R2 are not available for drone 2. Then a number should be divisible by both R1 and R2. Then a number should be divided by both R1 and R2 to be not available for both drones. That means both drones are charging at this time, right? Not available for both drones. That means that LCM of R1 and R2 should divide this number or this time t, right? So that means that every LCM of R1 and R2, both the drones will not be available, right? So it's basic number theory. Does it make sense for who asked this question? Abhimanyu, does it make sense? Yeah, unfortunately this question is very mathematical. So if your number theory and stuff is not very strong, it will be pretty confusing to understand how to do this. For this, I can only recommend doing more binary search problems, because actually when you do like any binary search problem set, you will have done at least a few questions like this for sure. It's a kind of a standard binary search topic to have, to find when you can do like some minimum X or minimum deliveries, minimum time for something, and then you need to figure out to split your time between different workers. It's kind of commonish. Like someone said, this same question came in OA or something before. So yeah, that's entirely possible. Right? See, as you can see, this is r equals 3 and this is r equals 4, right? Here there is no clash because these two numbers are not divisible by 3 and 4, right? And as you can see, at time equals 12, which is equal to LCM of 3 and 4, then they will have their first clash. Right? Right? When it is equal to 12, that means that 3 plus 3 plus 3 is equal to 12 4 times. So, and 4 plus 4 plus 4 is equal to 12 when you multiply 4 into 3. And that is the LCM of 3 and 4, right? And that's when they're gonna clash for the first time. And that time the drone will not be available. Yeah. So that's why LCM is present. So let me just summarize again. What we have found is a binary search condition for checking whether a given time is available or not. And that condition, first thing is checking if can under the given time. So all these places which is divisible by LCM, those cannot be used, right? So all the remaining time, in that much remaining time, can both the drones deliver all the packages? Okay. Then the second thing, in the time remaining for drone 1, can he deliver all his packages? And also in the time remaining for drone 2, can he deliver all his packages? So that's why these are the three conditions for your binary search. Fine. So your check function can run in big O of 1, right? So that is the check function runs in big O of 1. So what is the search space? The search space, we can just take L equals 0, that all the deliveries happen in 0 time. R can be very large number, so I just put it as 10 power 15 because at most 10 power 15 they should deliver, since there's 10 power 9 for each DI, right? So by 10 power 10, 10 power 11, definitely all the drones would have delivered. I'm just taking a large number for safety. And then you can just do a binary search. So binary search, L equals this. So while L is less than equal to R, mid will be L plus R by 2. Mid will be equal to L plus R by 2. Obviously, it's monotonic because if you can deliver at some time, if you have even more time, you will definitely be able to deliver. So we'll check the conditions. Check the three conditions. If it's possible to deliver, then we are going to check for even more time, right? We'll do L equals mid plus 1, else R equals mid minus 1, right? So then we can binary search the answer once we have our check function, right? So let's have a look at the code for this. Okay, so L and R is going to be our binary search bounds. Answer we have initially set to some large number. We'll minimize the answer, right? Okay. While as L is less than R, we find the mid. So that's the time we need to check. We will check if all the drones can finish delivery in this time. So can both the drones finish? So how many deliveries can this one do? It will be time minus time divided by LCM. And we're checking if D0 plus D1 is less than time divided by time minus LCM, time divided by LCM. Then similarly, we're checking condition for drone 1. So if D0 is less than mid minus mid by R0. Also, if D1 is less than mid minus mid by R1. So once all the three conditions are checked, if all are satisfied, that means we can do the delivery. We update the answer and R gets to mid minus 1. Otherwise, L will be mid plus 1, right? Oh, and by the way, these conditions are saying that basically if it's possible to deliver in this time or not. Yeah, so that's what it's checking. Okay. Fine, let's move on to the next question now. Actually, the final question seems like a bit of a repeat of an old problem with some slight change. So to be honest, while the final question is a lot of implementation, I would say that the final question, if you're not very good at math, you can still solve the final question, unlike C, right? C required some more math and some experience. Final question seemed more direct, but implementation heavy. So let's discuss it. So problem 4, right? Oh, we didn't discuss the time complexity of the previous question, so let's just do that quickly. It will simply be big of 1 to do the check. So the answer will simply be log of whatever your binary search bound was. We took 10 power 15, but ideally it will simply be log of, let's assume at most 10 times d1 we will be able to deliver, right? So at most something like this, log. So that will be the time complexity of the binary search we did. Fine. You use a digit DP kind of approach whose time complexity was exponential. Well, maybe you did not analyze your complexity properly, because this can be solved in big O of n squared log n ish time. Okay. So lexicographically smallest palindromic permutation greater than target. You're given two strings S and target, both have same length. Find lexicographically smallest string, which is both a palindrome of S and strictly greater than the target. If no such permutation exists, return an empty string. So basically, given target string, rearrange string S such that, first of all, S becomes a palindrome. So S is a palindrome. S should become a palindrome. S should be greater than T lexicographically, right? S should be greater than target. Also, X is smallest. So if there are multiple options of S, we should find the smallest one. Cool. So the main, I think, problem with this question is implementation. The idea itself, I think, is pretty simple if you think about it. Like seriously, if you think about it, the idea will be pretty simple. Okay, so let's think about how to implement this. Fine. So first of all, if we want to make S a palindrome, if we want that S is a palindrome, then what should happen is that a palindrome, every digit occurs twice, right? So for example, if we take an example of a palindrome, so first, observations on properties of palindromes. On properties of palindrome, right? And what is our observation? Our observation will simply be that whenever you have a palindrome like A, B, C, C, B, B, C, C, B, A, right? So every digit occurs even number of times. See, A has to occur both these places, B occurs both these places, here, C, right? So frequency of all the elements will be even. Okay, frequency of all the elements will be even. And if it's an odd length palindrome, then maybe you have some element with an odd frequency. So you can have an element with odd frequency. Let's say this was a C, and then again we have B, C, C, B, A. So then frequency of C is 5, right? So if it's an even length palindrome, all the elements appear even number of times. If it's an odd length palindrome, all the elements should even except one, which should appear an odd number of times. Okay. So I hope that makes sense. One element will be repeated odd number of times. Yeah, this problem is repeated, but this time they added that it should be a palindrome. Exactly. I think this was a problem just, I think, 4 PCDs ago itself. I had done the same problem, but here they added the palindrome check. It's a very similar thing, but yeah, the palindrome makes the implementation pretty complicated because you need to handle all these cases, like even odd case, and then you should only think about half the string, etc. Okay, so how do we proceed from here? So now first we're going to just check if it's possible to make a palindrome with these conditions. If not possible, we'll just return empty string. Okay, we'll just return empty string, and let me show you what the code for this looks like. So because this is based on implementation, we will see the ideas and we'll see the code next to each other. So one by one we'll do it. Okay. So what we're going to do is we're going to keep a map which counts each character, and then for each character we increase this map. So we're counting the frequencies. If the frequency is odd and the number total length, n is the total length, is even, so if there is an odd frequency but total length is even, we can just return empty string because it's not possible. Okay, if the total length is odd, we are going to store the middle character here. Okay, we're going to store the middle character here. So if the length is odd and if the middle character is not empty, then again there's two elements which are odd, so we can return that it's not possible. If there's only one character which is odd, then that just gets added to this middle character. Fine. So that's basically what we are doing. Cool. So we are figuring out whether it's possible even to make a palindrome or not. So that is this much of the code. Okay. Also, one more thing to note in the code. So in the remaining characters, okay, these we're going to pass them to a multiset. Okay, we're going to have them as a multiset like A, B, B, C, B. Sorry, C, C. Right. So ignore one half, like ignore the middle element and the second half. The first half we want in a multiset. Okay, so just note that first half store in a multiset. Okay, that's basically what we're doing. So for each element we are inserting it frequency divided by 2 times. So x is the character, y is the frequency. Inside this multiset we're going to insert it y by 2 times. Fine, we're going to insert it y by 2 times and we're going to store it. And the reason for this is it does not matter what order these elements are, right? We just need to know which are the elements that can be possible characters in the first half, and that's why we're going to store it. Okay, now what is the second property of palindromes we're going to use? So another property, observation 2. Once the middle element, so middle element can already be fixed. If it's even, the middle element will be empty. If it's odd, the middle element will be the odd frequency wala. So middle element is fixed. So once the left half of palindrome has been decided, has been fixed, decided, that means, or chosen, then the right half is also automatically chosen. Then the right half is also fixed, right? For example, if our string is something of length 6, our string has length 6, and we said that first character is fixed to be A, second character is fixed to be C, third character is fixed to be C, then that means that the whole palindrome is also fixed, because now last must also be A because it's a palindrome, second last must be B, and this must be C. Right, so fixing only one half fixes the whole thing. Okay, fixing one half fixes the whole palindrome. Okay, now, and here is the crux observation which was there in the previous problem, like the previous, this is a duplicate problem from few contests ago, and there was the same crux move, which is basically crux observation for the problem, and it's basically going to be like this. For lexicographically greater, okay, lexicographically greater, right? So the string S needs to be lexicographically greater than the target. S should be greater than the target. So the way we construct S, the way we have constructed S, basically what should happen? Let's say the ith character differs. Okay, let's say the ith character is the one which is greater. Okay, the ith character of S is greater than target. Fine, so this is the first point of difference. I is equal to the first point of difference between the strings. Okay, so that means that, let's say this is your target. Your target is something like A, B, C, Z, C, B, E, F, G, and let's say this is your first point of difference here. So that means that, first of all, if this is your first point of difference, that means that this whole string till now was equal. Okay, so till now this was equal. Fine, so that means that here this should be A and this should be B, correct? And because this is a palindrome, B and A get fixed here as well. Cool. Now basically, let's say whichever is the odd number element, that's going to go here, right? So this will be the odd number element. Let's call it O. O is the odd element. Now we just need to decide what will go in these two positions, right? What will go in these two positions. So if the first point of difference was at the ith position, that means that this should be some value. This should be some value which is just larger than c, right? It should be some value, some character just greater than target of I. Target of I. Target of I, right? So from our pool of characters, from our remaining multiset of characters, remaining multiset, I'm just going to call it pool. Pool basically means you can pick any character and you can use it, right? So it's like a swimming pool of characters. So from our remaining pool of characters, choose the smallest one, which is still greater than target of I, because we want it to be greater than target of I, but also the smallest, lexicographically smallest. So we choose the smallest one greater than target of I, and we'll put that character over here. Okay, we'll put that character over here. So let's say that was, let's say, D or something, or it was D or E or something. So let's say the remaining two characters are D comma E. So we'll put D over here because D is greater than C, and then finally E will go here in the remaining position, right? And then once we have fixed this, we have fixed that it's going to be A, B, D. We have fixed that it's going to be A, B, D. Now the remaining characters can be put smallest to largest, right? Because already first point of difference is established. First point of difference makes S greater than target. So for the remaining ones, we can just fill from the pool from smallest to largest, right? Fill from the pool smallest to largest. So we get the lexicographically smallest one, smallest to largest, right? So we can fix some. So let's say in the remaining pool there was like A, B, C, E, right? So we'll just fill A, B, C, and whatever are the characters, okay, in the pool. So what we need to do is, for every possible first point of difference, for every possible first point of difference, right, of difference from I equals 0, right, from I equals 0 to I equals n by 2. Why n by 2? Because the remaining characters of the palindrome are fixed, right? So that's why till n by 2, actually till n by 2 plus 1. In the odd case, the difference might be later, right? So from till n by 2 or n by 2 plus 1, or just keep it till n by 2 itself. So for every possible point of difference from I equals 0 to I equals n by 2, what we need to do is first, the first characters from 0 to I minus 1, right, they are fixed because they have to be equal to target of I, should be equal to target of I. Now the next character, the next ith character in the remaining characters, whichever is the largest one, sorry, whichever is the smallest one greater than target of I. So target of 0 to I minus 1, right? So S of I equals smallest character in pool greater than target of I. Now remaining pool can be filled in ascending order, right? Remaining pool can be filled in ascending order. So now basically we have filled the first half of the array of the string. First half, right? We have filled it from, let's say this was the first point of difference, so this would be equal. This would be the next line. This will be from the element, whatever it was, put it here, and then reverse this whole string in the back. So we got this whole string over here, right? So we got this whole string. We'll call it a temporary string. Now we'll just do some checks. We'll check if the temporary string is first of all greater than target, right? If it's greater than target, then we can do answer string is equal to minimum of temporary string comma answer string, right? So basically we need to find the minimum one, right? Minimum such one. So once we have built this string which differs at position I and is greater than the target and this is in ascending order, we will simply take minimum of answer with this. Make sense? So in every I position, which could have been a differing position, in every possible ith position, which could have been a differing position, we're going to try and find that is the point of difference, and then we'll find this. And also, if there is not enough elements in the pool, like to make these values exactly, then we can just break out of this process, because then we can't make that prefix. Please suggest resource for combinatorics. As far as I know, there are TLE videos on combinatorics, but to be honest, combinatorics for CP, there is not exactly a resource. Obviously, you can use the TLE Eliminators course for the videos, but it's mostly like you learn some basic theory of combinatorics from some math book. After that, you just solve problems and you see the editorial, and you'll understand how to use combinatorics for CP. Okay, like you need to know combinatorics in a math point of view, and then you can do problems and you can read the editorial. You'll understand how to do it in CP as well. And obviously, you need to know basic things like how to find NCR and all that. For that, you can just use Combinative Programmer's Handbook or something to know how to find NCR, how to find Pascal's triangle, that kind of combinatorics basic stuff. How to find inverse mod, all that you should know. Very basics for combinatorics. Anyways, returning back to the question. Sorry for getting distracted. Yeah. So we need to find a way to implement this. Okay. So let me just summarize the idea. Summary. For every possible first point of difference. So first point of difference, construct the string greater than target and lexicographically smallest. Right, and that is simple to construct. Smallest. Take minimum of all of them, right? Take min of all of them. And this construction we're easily doing because palindrome is in two halves. So the middle is already decided. The second half is already decided with the first half. So we only do this for the first half. We care about the first half construction. We don't care about the second half construction. Now the best way to code this out would, I think, be like a for loop and all. But in this contest, I was a bit like I was rushing to solve. So my code is using recursion and it looks a bit confusing, but I'll explain it anyways. It's the same idea. What is the time complexity for this? Time complexity analysis for this. There are n by 2 possible first point of difference. So we'll say that there's n ways to find the first point of difference. Then to construct the target, again n times we have to like edit the string, right? The string is n long, so n times n. And then the pool, we're using multi-set data structure for the pool, right? To find which characters are there and which is the upper bound for the current character. So that's why it'll be log n. So this can be solved in overall n square log n time. Okay, fine. Let's have a look at the code. Here I'm using slightly recursive approach. So my recursive approach is not needed. I should have just done with a for loop, but still, basically my recursive approach is this. Recursive approach is something, basically I'm converting the for loop itself to recursive approach. First I characters are fixed. Okay, first I characters are fixed. Now try next character as lexicographically largest. Try next car as lexicographically largest. Then make the ith character equal. Make ith character equal and call f of I plus 1 basically, right? Make the ith character equal and then try to match the I plus 1 character. Okay. So the way I'm doing it is I'm creating a string of best and I'm setting it to all of this curly bracket. If you know that the curly bracket is greater than all the characters, so whenever I do min of like best is equal to the minimum of best and the temporary string which I formed, then it will always become smaller than this. So basically by setting all to curly brackets, I've set it to infinity in a way. Okay, so curly bracket is ASCII value is larger than all characters. Okay, all ASCII value is larger than all chars. So that's why I'm setting it to this. Then I find my answer and I'll explain how this works. In the end, if the best is still equal to this, I return empty string. Otherwise, I return best. Now about finding the answer. So the first thing I'm passing is my current string. So in the start, my current string is empty. So my current left half, n is obviously the number of characters. M over here is the middle character. Okay, so if it's even, it will be empty. If it's odd, it will have one character over here. So it's a string with just one character. Pool is a multiset. So pool is the multiset of characters remaining. Okay, so pool is the multiset of characters remaining. Let me just note it down. So this is the left half of the string which is already fixed. Left half of the string which has been fixed so far. N and M you already understood. N is that. M is simply the middle character. Pool is the multiset of unused characters so far. Multiset of unused characters. Obviously, you know what target is. Target is given in the input. N is given in the input. Best will be storing the final answer. Okay, it will store the final answer. And notice that best is being passed by reference, so that when the whole computation finishes, the final best will have the updated value. Okay, so if you see the function signature over here, this is the current string, this is n, this is the middle string, this is the pool of multiset pool of the characters there, this is the target string, and this is best. So best is being passed by reference, so any change to best will be reflected in the global scope, in this scope as well, right? So that's why we're passing best by reference. Okay, so now the current string is already added to the left half, so I will simply be equal to that size, right? So if the current string is empty, then we need to add the 0th character. If the current string has one character, then we need to add the second character, so on, right? That is basically what we need to do. Okay, so now if I is already equal to greater than n by 2, then that's simply equal to just the current string, we reverse it. So current plus middle plus that temporary, and then this is just for testing. I had put C out, but let's remove that. If it is greater than the target, we take best is equal to min of this and target. Fine. So this is just for the base case when I becomes equal to n by 2 or more. Now, when we are in the ith character, we are going to find some lexicographically larger character in the pool, right? So we're going to use upper bound on the pool and find for the current position what is lexicographically larger. We will construct a temporary string. So we'll say that temporary string is equal to the current string. Push this lexicographically larger one. So this is the lexicographically larger one. We're pushing it. Erase it from the pool. Push everything else from the pool into it in ascending order. It's a multiset, so it will push in ascending order. Now we're going to make the string, right? So basically it will be the string plus the middle value plus the reverse of the string. So we just made a reverse of the string. So it will be the string plus middle value plus reverse of the string. If this is better than the target, then we'll do best is equal to min, comma, best, comma, temp. Fine. Also, because we removed a character from the pool, at the end we're going to insert it back once we're done with this, right? So this is if the current position can be converted to the first point of difference. Okay, so current position is the first point of difference, right? So this tries to make the current position the first point of difference. Basically what it's doing is taking the upper bound over here for the current character, making the string with the current character and comparing it to the best found strings. Okay, now if the character was not in the pool itself, we can just break. If the current character is not in the pool, just return. Otherwise we push the current character to the pool, to the string, push the current character to the current string. We erase the character from the pool because it's already used up, right? So erase this character from pool, and then try to find again recursively. So we don't need to use recursion. We could have used a loop also to encode this whole logic, but because I was in a hurry, I did it recursively. So then I will move to my I plus 1th character and I will try to match, try to make it lexicographically larger, then match that one and go to the next one and so on. You used all permutations of a string and sort them. but then that will be too many permutations because the total number of permutations would be very large. So you will get time limit exceeded. So Himanshu Tiwari, if you use your approach in general permutations and sort that, the time complexity will be very large because number of permutations is equal to n factorial. Okay, why brute force fails? Why brute force fails? Simply n factorial is too large. That is the simple reason. If you try to generate all permutations. Okay. So coming back to our approach, so this is about it. You can see that this is about n square log n because we're using a multiset. This function gets called n times, and each time is constructing a string of size n. So the overall time complexity is n square log n. Once we get our final best string, we just return it, right? So for this one, basically, what are the topics which were covered? The idea I think was very simple for this. It was simply just construction and greedy, right? Construction / brute force, not gonna lie, not greedy, was the topic for this, but main thing was implementation, right? So you need to be good at implementation for problem D. The idea that only first point of difference matters is very obvious, and then the fact that everything before should be equal, everything after can be taken as minimum, that is also pretty simple greedy idea or construction idea. But then the implementation of this would be a bit tricky. That's why you can go through my implementation. It's not a bad implementation, it's a pretty perfectly fine implementation. But ideally the best implementation would be it would do it in a for loop here itself. No need to do recursion because there's no actual reason for recursion over here, right? Okay, so that brings us to the end of this session. I would say it is slightly harder than average Leetcode contest in my opinion, but yeah, at least in the past few weeks we were getting very easy contests. It's not that easy compared to them, I think, but yeah. Okay, any general doubts or any clarifications at the end? No doubts. How to master multisets? To be honest, it's not much hard. Like this question did use multisets, but you could have used some other data structure also. But you just need to read the STL. Like if you're not familiar with STL, just go through the properties of STL and try to use them in problems. That's all. It's not something you specially need to spend time on. Just learn the STL set, multiset, unordered multiset, map, unordered map. So just learn those and just practice. That's it. Just learn what they do. I'm not able to solve third question. What topic should I master? You should master, I guess you should do binary search practice. So binary search and greedy, because those kinds of questions, if you do like a set of 30 binary search problems, you'll definitely see at least 4 or 5 of those types of questions. So that I can tell you for sure. How does multiset work internally? Multiset is implemented as red black trees as far as I know, right? So red black trees, if you have learned red black trees, so it's a self-balancing data structure and it makes sure that everything is in sorted order kind of, and also makes sure that it keeps tracks of which element should go where by balancing the tree. You can go read up on it. It's a pretty nice data structure, but it will take some time to understand how it works. You can also search for like visualization and you can see how you can insert elements into a red black tree and stuff like that. So you just need to Google it or read some book. Cool. Like you can insert some values into a red black tree and you can see how these values are being stored. And basically the red black tree ensures that it's a balanced binary tree, and it ensures that it basically it ensures that the height doesn't become too much by doing some rotations. That's what red black tree is basically. So that's I think how multiset is implemented in C++. Okay, all right then, guys. This brings us to the end of the session. Is Leetcode okay to crack good companies? Yeah, perfectly fine. Although Leetcode has less of those, what do you say? It has more standard problems and less of like unique, unusual problems. And I've seen that some OS they directly pick from like other sources. So, so oh, you're not able to solve third question in general. Fine. So for that, I'll tell you what topics you need. So ideally, you need to know these kinds of topics. For third question in Leetcode, I'll tell you what are the main ones. So prefix sum, number theory, stacks queues, binary search, combinatorics, right? So these are the ones which are used often. Prefix sums, number theory, stacks, binary search, combinatorics, sometimes greedy two pointers. These are the topics you need to learn, and roughly TLE level 2 or level 3 is what you need to learn. So either go learn these topics yourself or go learn it from the TLE course. It's for random fellow. So yeah, it's perfectly fine to use Leetcode as your primary thing, but I would suggest at least having one or two things, like have Leetcode as your primary, but occasionally do Code Forces or CodeChef or something like that, because they have more less standard problems, more like unique and ad hoc problems. That's why it's good to have some like broad experience also. Okay then, guys, this brings us to the end of the session. Before I end up, I just want to tell you about our flagship courses which are live now. These are courses in competitive programming which take you from a complete beginner level to, for example, you can solve one problem in div 2, solve two problem in div 2, solve three problem in div 2 level, right? So this is basically, if you do level 4, you're at expert level basically. So the course takes you all the way from complete newbie to expert on Code Forces or whatever platform you use, and you can see the topics which are covered. So basic C++, time complexity, searching, sorting, to binary search, right? So if you do advanced binary search, you'll have like 20-30 problems which will definitely cover problems which came similar to the Leetcode one C today, right? A lot of people found C tricky, that's why I'm saying that. Similarly, by the time you're done with this course, definitely you would have done enough practice for almost any OA as well. And this course contains more than 40 recorded lectures, 100 practice problems. So each of the courses, each level has more than 40 recorded lectures, more than 100 practice problems in each level, hints and video solutions for all of them. So there'll be like each problem will have hint 1, hint 2, hint 3. So increasing order of difficulty. There's also doubt support available 24/7, right? So if you ask a doubt, if you're stuck in a problem, you can just create a doubt on Discord. Within 10 minutes and at most like 15 minutes, some mentor will pick your doubt and you can get on chat with him and you can discuss and get your doubt clarified. Also, there's internal coding contests, posts, and then you have progress tracking, right? So if you feel unmotivated working alone, right, then you'll have motivation because you can see your name on leaderboard, you can see who solved more, so you'll get motivated for practicing. All right then, guys, thank you. I'm not sure if my explanation for C was that great today because it's very mathematical and I was not able to maybe give like a formal proof of it, but yeah, thanks for watching, guys, and hope to see you in more future PCDs. Do absorb the contest. Okay, thank you and see you next time. Bye bye.